Hi there and welcome to the DSO Nano training series. This series of videos will demonstrate how to use two different models of the DSO Nano. Up here on the right hand side of the screen we have the DSO Nano hardware version 1.1. Over here on the left side of the screen we have the DSO Nano hardware version 2. The major differences are that the buttons are arranged differently. It solved one of the issues with pressing the wrong button over here, and has a metal case. It's more shielding against electromagnetic interference, and a few little minor improvements. They both come with their own installed firmware from the factory, and we firmly believe that that firmware should be upgraded to the BenF series of firmware. The BenF series of firmware works on both units. It automatically detects which unit it's running on and makes minor adjustments for little discrepancies. So at this point in time, the current versions of BenF firmware runs properly on both version 1.1 hardware and version 2 hardware. This training series is developed using the version 1.1 hardware because I don't have a version 2 unit at this time. So all the screen functions are identical in both units once you upgrade to the BenF firmware. Throughout this video series, when I say press the M key, that's this key right here on the version 1.1 hardware, and usually you either press it or you press and hold it. The same function is obtained over here with the OK key on the version 2 hardware. Like I say, the screens will be identical in both systems. It's just this button is used instead of this button. And the other difference between the two units has to do with connecting the probe compensation signal. So let's take a look at that. When we connect the compensator signal with the version 2 hardware, you will need two probes. Two probes come with the unit. One probe will plug into the probe compensation signal, and the other probe will plug into the channel 1 input to the oscilloscope. So let's take a look at these two probe locations. Here we have a line diagram out of the DSO Nano version 2 manual, and you notice that this is the left side view. If you're looking at the front of it right here, then this would be the left end. So I would suspect that it's this side over here. You plug in the top jack. Here is a probe jack, that's for your oscilloscope probe, and the bottom jack down here is a signal generator, which generates a signal. So anytime you see us on the model version 1.1 hardware in the video, anytime we connect the probe to the signal generator, it'll be different. In your case, you can plug in these two leads, connect the connectors of two leads together, and you'll have the same configuration. Okay, this is the DSO Nano. Up in the left hand corner we have the trigger mode, which is constantly displayed. We have the trigger transition choice, which is constantly displayed. We have volts per division and microseconds per horizontal time division constantly displayed. Down at the bottom we have trigger level, it's always displayed. We have the delta voltage between the voltage cursors, delta time between the time cursors, and we have a variable display here and up here at the top. Let's take a look at that for a second. We have a measurement system which shows all these measurement parameters. Whichever parameter you have highlighted when you leave the pop-up menu is a new parameter that shows up here, and it shows up down here telling you what it is. Anytime I scroll up to different menu choices, come back to the measurement menu system, I can change the measurement function by pushing the left or right arrows. One more, measure frequency. Down here under the frequency output, that's the actual probe compensation signal, and we can vary the frequency output, and we can also vary the frequency duty cycle. And down here at the bottom is where it shows those changes that we make. We also have the ability to change the probe attenuation, which is down here right now. It's times 1, times 10, times 1. Our grid intensity, which you can probably see,
And each volts per division step has its own calibration of offset and gain. And we can save those calibrations of offset and gain into permanent memory, non-volatile memory. Moving up the line here, we have trigger modes. If you watch the top left corner, I'll step through the modes. We have normal, single sweep, auto. We also have a mode which is called fit. Fit makes a waveform fit on the screen so you can easily analyze it. We also have normal volts per division. We can change that. Notice we found out the fit mode, as soon as we change something, it's back to the auto sweep. And we can change times per division, obviously. Here we have two voltage cursors for measuring voltage between any 2 points on the screen. Here we have time cursors, T1, T2, to measure any time interval on the screen. We have trigger position, so we can slide the signal left to right through the acquisition buffer and look at different parts of it. This is very useful when you're looking at serial data streams for a certain pattern. We also have a file input-output system right here. We can save images, we can save the entire acquisition buffer, we can save profiles to an SD card that's removable. It's a hot swappable SD card. We can load profiles, we can save, load, and show reference waveforms on top of the existing waveform. For example, there's a reference waveform on top of the square wave. We can also hide that reference, which is shown down here. Show and hide. It has a battery status indicator. When you plug it into USB cable, now the Nano becomes a card reader for the SD card, so you can read the data without removing the SD card. It also allows the USB cable to charge the battery of the internal battery within the Nano.
One last item with the videos is that I'm using a digital still camera with movie capability to take the videos. The camera has to be about 3.5 inches from the Nano device, therefore it's hard to see around the camera, and I have to use the sound system in the camera. So pardon the reflection on the screen and the sound quality when it's on the movie camera.